Finding reference angles. To find a reference angle, first of all, if angle A is 20 degrees, you have to think about what the angle is. Angle A being 20 degrees, we know that's going to be in quadrant 1. So this would be angle A, that would be 20 degrees. All right, because remember, quadrant 1 was between 0 and 90 degrees. So that's angle A. My reference angle, everything in quadrant 1 has the same reference angle. So the reference angle refers to this angle right here. Call this angle theta. So that theta refers to this angle right here. And basically whatever it is in quadrant 1, the reference angle is always the exact same thing. Now, it's going to be different. You have to do different things in every other quadrant. But in quadrant 1, if it's less than 90, the reference angle and the angle are equal. So the reference angle for this angle, 20 degrees, is actually 20. And I'll just write reference angle is 20, because that's exactly what it is. So if I had to find a reference angle for a bigger angle, for example, if angle A was 130 degrees, I'll first plot a 130 degree angle, which we have initial side here, have a terminal side back here. So this will be 130 degrees actually looks like. So that should be 130 degrees. So that's what it looks like. It's this big angle right here. It's obtuse. The reference angle refers to this angle formed right here. So we're looking for that little piece. And the way we find that is, we just have to remember what quadrant we're in. All right, so seeing as this is now quadrant 2, you go 0, 90, 180, 270. Again, that would be 360. So if I'm looking at this quadrant, I'm looking at, well, if this is 130 and that's 180, well, what's the difference between the two? So to actually get from 130 to 180, how many more degrees is that to make up that little piece? So basically you probably know, I'll just take 180, I'll subtract 130 from it, 130, and why does it leave you 50 degrees? So I know my reference angle in this case, so my reference angle is 50, reference angle equals 50 degrees. So suppose it said find the reference angle if angle A is 220 degrees. So what I would do is I would graph a 220 degree angle. And if you remember, this is 0, this is 90, 180, and 270. Well, 220 is somewhere between 180 and 270. So I know this is my initial side, this is my terminal side, and the angle will look something like this. So this is what 220 degrees actually look like. So now, my reference angle, basically you have to understand this reference angle is always what it takes to get back to the x-axis. So it's always the angle that I need in between the angle that I was given and the angle that takes you back to the x-axis. So you wouldn't want to use that space. Don't ever use that space. The one that takes you to the y-axis. You always want to look here. So if that was the case, I'll actually just write the equation. Well, what is 220 subtract 180? And you get the difference between both of those. So you wind up having 40 degrees. So my reference angle, this angle right here, must be 40 degrees because from 180 to 220, that angle there is 40 degrees away. So it's 40 degrees. So that's my reference angle. So I write reference angle is 40 degrees. Gave you the angle 295 degrees, and direction was find the reference angle. If angle A is 295 degrees. Well, first of all, you have to ask yourself what quadrant is 295 in. So that's 0, this is 90, this is 180, this is 270. 295 is definitely greater than 270. So 295 is definitely in the fourth quadrant. So yeah, so 295 degrees should definitely be in the fourth quadrant. So my initial side will be here. My terminal side will be down here. So this is 295 degrees. 295 degrees. All right, so that's what that is. Make that look a little better. So that's what it looks like. And you're looking for the reference angle. So again, it's always the angle that takes you back to the x-axis. So it's this angle right here. So this would be theta. So I'm looking for that angle that gets me back to the x-axis. And if you remember, that's 0. It's also 360. So in this quadrant, I would say, well, what is 360 subtract 295? And you probably just calculate to figure out what that is. So you should find the reference angle 65 degrees. So this angle right here, 65 degrees. So you write reference angle equals 65 degrees. So that's how you find reference angles when they're all degrees. So in the book and in online textbook and everywhere else, sometimes they give it to you in radians. So this is our next example. So we need to find a reference angle for angle A, and A is 2 pi over 3. If you remember that in radians it goes 0, and then it would be pi over 2, and then the next one would be pi, and this would be 3 pi over 2. So it's pi there, and that's pi here, and this, instead of being 360, would be 2 pi. So that would be the same, that would be all the quadrants and radians. So if that was the case, you can figure out what 2 pi over 3 is and which angle that's between. When I was in your shoes, I always had trouble trying to figure out, where 2 pi over 3 would be because it's not in degrees. I'm more comfortable with degrees. So because of that, I would still change this angle into degrees. So I would take 2 pi over 3 and I would convert it into degrees. And remember from previous lessons, you basically take 2 pi over 3, and to convert into degrees, you multiply it by 180 over pi. So the pi's will cancel out. 3 divided into 180 gives you 60. So you should wind up having 2 times 60. 2 times 60 gives you 120 degrees. So I know that 2 pi over 3 is really 120 degrees. So I know that's going to be in this quadrant. So I'm looking at this angle formed right here. That angle is 120 degrees. So instead of having pi, I would think about that being 180. So now I'm still thinking, well, if that's 120, I need to figure out what angle I need to get here, to get this angle right here to find my reference angle. You probably subtract 120 from 180. So 180, subtract 120 from it, you wind up having 60. So your reference angle is 60 degrees. So that's what it is. And basically what I decided to do is, whatever is in radians, I will convert it into degrees, and then work with it just like we did in the previous example. Then we also have a case where we have to find a reference angle, and the reference angle is a really big angle, like 400 degrees. So what I would do is I'll graph it, but to graph 400 degrees, we know to find coterminals to it. So a coterminal to 400 degrees, you take 400 and you subtract 360 from it to find its coterminal, and the coterminal to that would be 40 degrees. So I know that's in quadrant 1. 40 degrees looks like this. So this is 40 degrees. So this is the angle. And remember in quadrant 1, the reference angle and the angle are both the same thing. So I know in this one, my reference angle is 40 degrees. And I write reference angle is 40 degrees. And sometimes they don't give you big angles, they give you negative angles. So in this case, it says find the reference angle for negative 300 degrees. And it's just like our last example, where you can think of where negative 300 is, or I'll just find a coterminal to it. So I'll take negative 300 Now add 360 to it, and I know that my angle is really 60 degrees. So I will apply a 60-degree angle. And a 60-degree angle will definitely have an initial side here and wind up being quadrant 1. So this is the angle, 60 degrees. And again, like the last example, the reference angle and the angle are equal. And that's it. That's all there is to know about reference angles. So you know all you need to know to get started in finding reference angles.